right, so we're going to talk just a little bit about like signal flow. So we can address things like distortion and, things that might be having issues with the signal flow. And the biggest thing that you're looking at signal flow in the microphone is components that might be doing something to the signal, components that maybe the grade of the components might not be as good as the grade of another microphone because of the components they've used. And, the biggest thing to tell you about this is you should go back and look at that series I did on audio engineering. It just kind of opens up some doors for you to take a look at a few things so that when you're dealing with things like that, you have a little bit better understanding what you're looking at. But basically, you kind of want to understand what the signal flow is through the microphone, some wiring diagrams, maybe what materials they might use and things like that. One problem with this is that I went to this site here for the Shure SM57, and this is a condenser microphone, right? Well, this microphone, this is what we get. So, there's not a lot of information there so that you can have base any kind of conclusion about the components or, the quality of the components, about what might be there, and that might be trade secret kind of stuff. Was without you completely dismantling, the microphone to find out what exactly, what kind of conductors and transformers or, material they might be using in there. And we've already talked about that being a problem with the actual microphone transducer. So, but that can be a huge issue. And so basically I wanted to make a note of that, but the problem is that you're going to probably run into is having an issue getting really good information to base anything about that. So basically what you got for the most part is to try to understand what the signal flow is in your microphone, and then you can, if you're having issues or if you're trying to determine which one is better or not, you may or may not have a lot of problems trying to understand what microphone might be better because of components. That might be boiled down to the price range, because we already talked about how we're going to run into that when we're looking at the actual microphones, that they don't want to tell us, how they put that magnet together and what components are in it. They don't want to tell us the Mylar mixture they used for the diaphragm, because they don't want Bob to know what they did, because then Bob's going to copy their microphone and sell it for $59.95. So you're going to run into those problems. So whenever you're dealing with the signal flow inside of the microphone, you may have issues. You obviously want to understand what the signal flow is, and I definitely want you to go back and watch those videos so that you can have some understanding and what's going on inside of your microphone as far as the wiring diagram and how the components are put together. How much that might help you is very dependable on how much information you can get from the manufacturer. All right, the next thing I want to say, let's say we bought this microphone here. Now, without you being, understanding, electrical engineering, that how well you going to understand what's going on there? You're probably not, it's, pretty obvious that you're not an audio engineer, you look at that and you don't know exactly what that's doing. You're not an audio engineer. It's that simple. So, me, myself, I could tear that apart and I'd eventually figure out what everything did, but it'll probably take me a while. But the whole idea is how much of that, how deep are you going to get into that? So, when you're dealing with a signal flow and a micro signal flow, that, those kind of things, if you can get the information, you can figure out what's going on there. And one piece at a time and one step at a time through the signal flow to see what's happening so that you can make some, informed decisions about what that microphone is doing. Because a lot of times that you're just not getting that information when you're trying to figure out the signal flow, to figure out what's, happening before that hits here and then what's coming out that butt end of that microphone, that sometimes it can be a little complex. So, and you have to understand that what's going on there is that no matter what, is that they're trying to, enhance the sound. They're trying to repair issues that you might be having, that they might be having with whatever type of transducer they're using, or trying to enhance it or fix issues with it so that it functions better or in some way for some different type of application. And, there's a lot of different things that can be taken into consideration when looking at that. So as far as the signal flow goes, I definitely recommend that whatever microphone you're getting, some microphones, the signal flow is very simple and very basic, and the wiring diagram is just, it doesn't take nothing to understand what's going on there. There's a transformer, a wire, and that's it. It's like some mics can be that way. Some of them can't be. Some of them can look like this, or even worse. There's a lot of stuff going on there that you need to understand what's happening. So the best thing to do with that is, my suggestion is that, try to get, to keep it as simple as you can. And when you're dealing with more complex systems, that, you're really going to have to go back a step and dig into some things that, may not be, that you thought were, part of just dealing with microphones, because it's more dealing with audio engineering, because basically they're trying to deal with audio engineering difficulties to try to get that microphone to sound as good as it can in some certain type of environment or for some type of application. And, that's the whole point of audio engineering, that microphone, to where it can function in, the environment that you want it to. So that can be very complex. And if you've watched all the videos that I put on this series, that you've got a pretty good understanding of that already. And you probably already understand, if you're looking at those components, if you messed around there at all, that you probably get a pretty good understanding of what's happening there just by looking at it. And if you don't, that you probably should go back and take a look at those. But we're not going to get too in depth in that, because that we could make 50 videos on that. So we don't want to make 50 videos on that. We just want to know that basically we're going to have issues in that. No matter how we look at it, no matter what we do, there's going to be times where we're just stuck with what, Bob has given us, because Bob's not going to give us all the information about this microphone, because he doesn't want Tim to know what's going on in there, because otherwise Tim's going to stamp it out in his, factory for $59.95. So we might have some problems there. And if we're not actual audio engineers, that sometimes it's going to be a little hard to tear that microphone to understand exactly what's going on without, tracking down every component in there and testing every component in there. Everything from the, from the magnet to the mylar and everything else, which means that, that entire investigation might get a little expensive, and it might get a little time consuming, and it might get a little complicated. So we have to understand that some things in the signal flow in the microphone just are not, feasible to investigate too thoroughly. We can investigate some of it, some of the information they're going to be so happy to tell us about their microphone, and some information they're just not. So get a hold of any information you can about the signal flow and the microphones you're dealing with, and take it as far as you can. But understand that there's more than likely you're going to run into a type of a brick wall, that you're not going to get any information, because they don't want you to have any more information than that. And if you want to be an audio engineer and come work at their facility, then they'll give you all the information you need, except for now, you have to be killed if you tell Bob, so I don't know, so I know that's messed up to dead end you like that, but basically that's what you're looking at, and it's very hard to deal with that. So you basically need to look around at some microphones and what their components are, and try to keep things as simple as possible if you can. And sometimes you just can't to get good quality. So I think we've kind of addressed that, because most of the time when we're dealing with the signal flow in the microphone, we're trying to deal with, what it might be doing to enhance it. What audio engineering applications have been applied to it to enhance the audio, or take, things that might be causing problems into account, and, to compensate for it. But without being able to get any information, there's only so much we can do with trying to understand what's happened inside of it, without, buying one of them, tearing it completely apart, tearing all the components apart, testing them and finding out where they came from, what their components and the makeup of their mixtures are. It can get really complicated, and don't think it won't, because it will. They spend lots of money trying to make sure that that microphone is better than Bob's microphone, so that you'll buy that microphone. And sometimes that, it's really hard to tell when you got a microphone that's really close to the same price range that you can't get any information about to find out about the signal flow and the components. Then why would you buy that one? Does that make sense? So you basically have to trust, the sound, you're trying to trust, what's hitting it and what it's coming out to, and being able to analyze the signal to see what's going on, rather than being able to actually analyze the components. which is kind of backwards way to do it, but basically that kind of what you get stuck with sometimes. So take it as far as you can and then look at the signal as far as what's happened to it, and you know, to get a better understanding of what could be happening. I've showed you plenty of equipment that can show you impulse responses, frequency responses. You've got your DAW to see what's happening in there, and the spectrum, and the decibel levels, and you've got all kinds of pieces of equipment to try to figure out exactly what's happening in that microphone and how it might be affecting the signal that you're coming into, and to, you know, make some better informed decisions. And the problem with that is having to buy 10 different microphones, and you might end up a lot of times getting stuck with Bob and Timmy's and Jimmy's review and trying to figure out if any one of them aren't a complete idiot so that you can get a really good analysis of that microphone. And that's really hard, you know, because you never know, you know, Bob's really good at what he does and Timmy's an idiot, you know, and it's like, and, you know, you watch 4 hours worth of Timmy's videos and, you know, he doesn't have any idea what's going on there. And that can be very difficult because there's been some times where I've said some things, you know, and I'll be like, oh, bro, well, I might have messed up there, you know. And it's like, but I try to get as informed as possible. And whenever I'm dealing with things like this, that something like this can be, you know, that's audio engineering, you know, and you're really going to have some pretty good understanding of, you know, audio engineering to even deal with that issue. But if you can take it one step at a time and deal with it as you've got that signal coming through, a sine wave, what's it doing to it? Why is it doing that to it? And why is that microphone dealing with that better, you know, or not as good, you know? And sometimes it's not just the signal. Sometimes it's the early and late reflections of impulse responses or the frequency response. And all those components can be doing different things to that. And it doesn't take much to screw that whole signal flow up. So, you know, the bottom line is to try to help you get a better, or, you know, microphone, or ones that are comparably priced, to understand what the difference is. The actual difference is going to most definitely be in all the things that we can't get information about. So the only thing we can do is try to figure out, you know, based on the information that they will give us, which sometimes that's a huge clue. Sometimes you can go looking for the signal flow between two microphones that are very comparably priced and find out one of them don't want to give you no information, the other one's giving you some pretty good information, and look at the quality of the information that you're getting and the response from the people that are making it, to give you a little bit better understanding that, you know, with that type of time they've spent trying to explain it to you so you'll buy their microphone, they may have put that kind of quality time into the actual microphone. That's not saying they will, you know, but it's a good sign. It's just like, you know, me, myself, you know, a piece of software. If the GUI sucks and it's just lame and it looks like an idiot put it together, there's a good chance that they spent about as much time on the program. That's not always true. I've got some scientific programs that look like an idiot put together, but the actual algorithms, you know, have very, you know, pertinent scientific, you know, value and work very well. But a lot of times that's not real in this industry. And sometimes it's totally backwards. Sometimes the microphone and everything looks just awesome, but the actual structure sucks. You know, does that make sense? It's like they painted it pink and put little big boobs on it or something. And, you know, you got, you know, garbage, you know, that you bought, with all due respect, you know, and it's like, you know, so you got to be real careful of that and think of that and go inspect as well as you can that signal flow and the components that are in there, to base them, you know, to try to get as much information as you can to make accurate analysis of the signal flow and what's happening and how it's processing the signal. So I hope that wasn't too long and drawn out, but I certainly hope that gave you a little bit more insight into that, so that when you start doing that you don't get totally frustrated by that, because I have. There's sometimes software, hardware, all kinds of things. I can't get no dang information, so I can't make any concrete decisions about what's going on between those two pieces of hardware, because I have no idea what's going on inside there without buying one and tearing the whole thing apart. So that can be frustrating. So try to deal with it in the ways that I've stated. So I think we've kind of addressed an issue that's very difficult to address, that we're going to hope that we can address a little bit better as the series goes along. But I definitely want to address that, so as we're going along, that is in your mind, so that when you're dealing with those issues, that you may run into those kind of complications. So let's go on to the next issue.